There are two terms you need to know before starting database management system. First one is data and second one is information. So let's see what data means. So data refers to a collection of raw facts or figures that can be processed to derive meaning or knowledge. In easier terms, we can say any fact that can be stored is a data. So let's see from an example. Consider an example of orange. So what does orange means here? Orange can either be a fruit or can be a color as well. So we don't know what does orange means here. Maybe it can be a fruit, maybe it can be a color. So now comes information in the picture. So what is information? Processed data is called as information. So consider I am writing here as fruit. So now we are clear that we are referring orange, which is a fruit here. Consider I am writing it as orange and I am giving it the name as color. So now we are clear that here the orange we are referring to is the orange color. So basically what information does now, it gives a meaning to the unprocessed data. So data basically is a collection of raw facts or figures. You can also take an example. Consider there is a value called as 12. So now here, are you getting anything ki what is 12? Maybe it could be an age. Maybe it could be a roll number. Maybe it could be a pocket money. So sorry, it couldn't be, but still I'm just taking an example. So here 12 can mean anything, like it is just a raw fact which is present here. Consider I'm giving it as 12 is the age. Now it is giving some process thing na ki okay, age 12. So my data is my brain is interpreting is ki okay, 12 might be an age of a person. So this is like what happens. So basically there is a data. We provide some additional information to it, like we provide some additional things to it and it gives me an information after processing it. So basically I have a data 12, I give it like age. Now my brain will process ki 12 and age. Okay, 12 could be an age of a person. So it gives me an information. So basically this is all about data and information. Let's see what's next. Okay, so database is the next thing we are gonna see. So what is database? Database is basically a collection of interrelated data. What does this interrelated data means? So there are also two pointers, like it can be stored in the form of table. It can be of any size. Now let's see, there are two examples of databases which are present here. So one is multimedia database and second one is college database. Consider that I am having a table which is having all information about an image. Okay, the pixels, the height and everything. I'm having another table which is having all information about a video, like pixels, length, everything like that. So kind of they are interrelated to a thing which is called as multimedia. So multimedia consists of images, videos, graphics and much more thing. So basically image and video kind of have a relation and these both interrelated data forms a multimedia database. Now in this example, there is a staff. There is a student. Consider there is a table 1 about the staff details. There is a table 2 about the student details. So kind of staff and student have a relation that they could be a part of a school database or a college database. So they are kind of having a relation. So they can be a part of college database and they are having a relation. That is why they are called as college database or database, like collection of a interrelated data. Now let's see from an example. So here you can see the example in. Consider this is an A1, this is a A2. So we have given the name to the table. First one is having an ID, name and subject. Second table is having ID, name and place for the same person, Rahul, Raj and Ritti. So here I have given the details about Rahul, like the ID is 1, the subject is physical education, ID is 2, the subject is economics, ID is 3, the subject is IT. Here I have given the information like ID is 1, the place is Delhi, ID is 2, name is Raj and the place is Kolkata, ID is 3, name is Riti and the place is Mumbai. So whenever I combine A1 and A2 together, they gave me a table A3 which is kind of having a relation, like it here if I combine A1 and A2, I can get a relation like the ID of Rahul is 1, the name is Rahul, the subject is physical education, and the place he lives in is Delhi. So basically there is a collection of interrelated data. So this is why database is called as a collection of interrelated data. Now let's see that why we need database. There was already existing file system. So what was the need of database? So let's see what is file system. So basically an operating system approach for organizing and storing data on storage units like hard drive is called as file system. So basically it is an operating system approach in which we store the data on storage units like hard drive. So what happens is, consider I am having a file called as a.txt and I have written some data like ID, 1, name, Riti. I have written some data in it. Now I want to save it. So what it will do is, it will go to the file system and the file system will call the hard drive to save that particular data inside it. A.txt. So basically you can say that hard drive or a file system basically acts as an interface between the user and the data. So basically it acts as an interface. Now you would be having a doubt ki, okay, using this file system we were storing the data, we can also update the data, we can also delete the data. Then what was the need of databases? So basically there are some disadvantages of the file system. So the first disadvantage of file system is data redundancy. So what happens now ki, let's go to the 1980s time. So we used to have some registers. In first register, there might be some information about me, where I live, like the place I live, what is my age, and consider that there are 2 registers, okay? Registers. So there is 2 registers, register 1 and register 2. Register 1 is having knowledge about my name and my age. Register 2 is also having some data about my name and the place I live, okay? So basically there are 2 registers. Register 1 and register 2. So register 1 is having data about my name and age. Register 2 is having data about my name and place. But again, there is a thing na ki if it is having data about my name, information about my name and age, why not to incorporate place in the same register? Why to have multiple registers for a same person? So I'll be having one register with my age, one register with the place I live in, one register with the attendance, one register with some other data, one register about how much fees I pay. So there would be plenty of registers, right? So like kind of data is being redundant here, like it's being used in many formats at different places. So that is the major disadvantage of file system, that there is a data redundancy, that in many registers the same data is present about the same person. So that is the drawback of a file system. So this is something which we can achieve in a database management system or databases. Now the second one is poor memory utilization. Obviously, if I am maintaining hundreds of registers for a same information for a single person, there would be memory which would be filled. So there would be a poor memory utilization. Now the third thing is data inconsistency. So consider I am having 2 registers, register 1 and register 2. So register 1 is having my name and age. Register 2 is also having my name, which is Riti. Age, which is not 18, but I'm taking that 18, and please consider it as Bangalore. Okay, so after 1 year, obviously I'll become 19 years old. So consider I'm making the change in this particular table register, that I'm 19 years old, my name is Riti and I'm living in BLR. But in this particular register I forgot to make the change. So you can see that there is an inconsistency between data. The age is 18 here and here the age is 19. So there is data inconsistency which we can see here. So that is also a drawback of file system. Now coming to the fourth thing, that is data security. And data security is like the topmost priority. So we want our data to be secure enough. We want some security, some integrity in our data, some principles which should be in our data to restrict usage from like external people couldn't use my data, and which is not possible in file system. So data security is also something we achieve much more in databases rather than in file system. So that is the reason we introduced databases and we are not using file system. Now database management system, finally. So database management system is basically made of two words. First is database and second one is management system. So database, as we know, collection of interrelated data, and management system is basically a set of rules we use to access that data. Set of rules which we use to manage our data is basically called as management system. So the acronym database DBMS stand for database management system. User can access data, save data, retrieve it, update it, and manage it safely and effectively with the use of a software, program, or combination of programs. So again, the same thing, that in the database management system is basically a software which acts like we are having a database, right? In that database, consider we are having a database D1. So in that database, this is DBMS and this is an end user. So consider I am an end user. I want to make some insert into the database. Consider that there is a college database and on next day someone takes an admission. So I want to insert the data of that particular person who has taken the admission. So what I'll do, I'll use DBMS. Basically, DBMS is a software which is used to make some manipulation to the database like insert, update, delete, save, and much more things. Now, the presence of rules and regulations in the management system is crucial as they are necessary to uphold and maintain the databases effectively. So there should be some rules and regulations to manage the database so that we can uphold the database effectively and maintain our databases as well. So that is management system. Now, this is the application of database. So there are 3 applications which I have noted down, but there are much more applications of database. So the first application is database is being used in schools and colleges. The second application is database is used in banks. And the third application is database is used in airlines. So here we can see the application of database. Now the first application is school and colleges. So DBMS is used to create, maintain a student information system that stores student records including personal details, academic performance, attendance, and extracurricular activities. So consider I am a school student, okay? So whenever I take admission in my school, there would be an insert, like there would be already a school database which would be maintained. School DB, which would already be maintained, which would be having data about the teachers, principal, staff, and much more things, students. Now consider I am a new student who takes an admission in my school. Okay? So whenever I take admission in the school, there would be some data related to me like my name, my age, which class I want to take admission, consider nursery. So there would be many data about me, that what I am, like what is my name, what is my age, which class I want to take admission, and much more thing. So basically that particular data is being stored in this particular database to keep the record of me. Okay, Riti is a girl which has recently taken admission to the school. Her name is this, her age is this, and she had taken admission in nursery class. So I'm just kidding, but I'm just giving you an example. Don't take it seriously. So these kind of data needs to be stored in the database. So here the application of database comes in, because again, if you are maintaining many registers about people who are taking admission, people who are leaving the school, people who have been promoted from nursery to prep, like there would be numerous number of registers, and it would be hard to manage every data. Then again, data inconsistency, data redundancy, there would be many things which would occur. So we use the database approach for this. Now again, in the bank, DBMS is used to maintain a centralized and secure database of customer information, including personal details, account numbers, contact information, and transaction history. So consider I am right now in bank. You come to me, you say that I want to open a new account in your bank. So right now I'm having all the details about all the staffs who are working at the bank, all the people who have account with us, and much more things. So now a person comes in and he or she says that I want to open a new account in your bank. Again, he or she would be having some details like account number would be generated, then amount balance she or he needs to store in their account, and much more things. So that particular data I need to feed in the database. Now again, there is one more use case. Consider that today I deposited rupees 1000 to my bank account. Next day, I pull out 50 rupees from my bank account to buy some chips or something. So right now, what would be the current balance of my bank account would be 950. So there are some regular insertions, update, delete, and like some addition, subtraction as well in the database. So here also database comes into picture. So as you can see on my screen, there are many databases I have listed down, almost 11. But we don't need to know like in depth about all the databases. There are some database we should be knowing a bit more depth, but we can get a slight idea on all the databases. So let's start. So on the very first, we are having relational database, that is among the most widely used databases. So in relational database, what happens? In that database, there is a collection of data items, which is kind of having some relation between them. So consider I am having a database or a table I am having. In this table, there are certain number of rows, certain number of columns, and these are having some relations in between them. So basically that is a relational database. Now coming to the second thing, that is NoSQL database. NoSQL means not SQL. So basically in NoSQL database, what happens na, ki they don't follow any kind of format. So the data items are kind of stored in a key value pair. So what happens ki we have a key and we have a value, and our data is stored in kind of this key value pair. Consider an example, we have a key as place and the value being stored as Mysore. So there is no restriction or there is no relational way it follows to store the data. Like in relational database models, we basically use rows and columns to store the data, and it's like corresponding to this row, there should be this data, corresponding to this column, there should be this data. So we don't follow that much of strictness or that much of relational approach or a traditional relational approach to store our data. We store our data in the form of key value pair, which we basically do in a hash map. So now the third one is object-oriented database. As the name suggests, object-oriented. So basically whenever the data is stored in the form of object, it is called as object-oriented database. We will be looking more about this in the further slides. Now fourth one is in-memory database. So what happens in in-memory database? Now the database or the data is stored in memory, like it is stored in the primary memory, not in the hard disk or any SanDisk or SSD anywhere. So basically it is stored in memory. So that is why it is called as in-memory database. Now the fifth one is time series database. So in database, what happens now, ki consider we are having a series of events on a different time intervals. So that kind of events or that kind of time intervals are basically like a time value pair. It is stored in this time series database. Now sixth one is spatial database. So basically spatial is something like a kind of a, we can say a 2D thing or something which represents something. So basically in spatial database, what happens is ki we generally tend to store the geometric space in the database. Don't worry if you're not getting these terms, because it's just a basic intro of these databases. You don't need to know in much more depth about all these databases. Now the seventh one is multimedia database. So as the name suggests, it is a collection of databases which is having like collection of data which is having text, images, graphics, and much more things. Now eighth one is columnar database. So basically in this database, every data is stored in columns, not rows. Now ninth one is XML database. Again, as the name suggests, in this database, the data is stored in the form of XML. Now 10th one is NewSQL database. So what NewSQL database does na, ki there might be some gaps in relational databases. There might be some gaps in NoSQL database. So basically it becomes a bridge for all the gaps between SQL and NoSQL databases. 11th one is blockchain database. In this blockchain database, the data is stored in the form of blocks. So basically it is kind of a decentralized way in which data is stored. So data is basically stored in the kind of blocks. So there are 4 databases which we would be looking in depth, because relational database is kind of most used database. NoSQL database is also widely used, and object-oriented database and in-memory database, I guess according to the semester point of view, you should be knowing about it. Not very much in-depth knowledge, but you should be having some knowledge about it. So let's have a look on all these 4 databases. So basically the first one is relational database. So these databases structure data into organized tables that have predefined connections between them. So as I told na ki whenever like tables have some connections or have some relations among them, it is called as relational database. So consider there is a table 1 T1 and there is a table 2 T2. Consider that they have a kind of a relation between them. Relation, how you can say what kind of relation or something like that. So let's see. Consider there is a table which is having my name and my roll number. Consider the table T2 which is having my name and the place I live in. So this is also a data about me, and this table also contains a data about me. So they have a relation which is like the information about me is also present in this T1 and the information about me is also present in this T2. So this is kind of a collection of interrelated data. So this is like a connection between them. Now data manipulation and query performed using SQL. So basically in these kind of databases, the data manipulation like kind of insert, update, delete and every other operations are performed using SQL queries. Now well-known databases are MySQL, PostgreSQL, Oracle database and Microsoft SQL Server. So this is all about relational databases. Now coming to the second term, that is NoSQL databases. So NoSQL database are created to handle data that does not fit neatly into the strict setup of traditional relational databases. So what does this means? Again, like few minutes ago I told you what does NoSQL database mean. So basically NoSQL database, what happened now, we don't store in a form of rows and columns and we don't do any kind of queries ki theek hai, from this row we are getting this particular things, from this column we need this. So we don't do store data in that format. Basically data is stored in the form of key value pair, which I earlier explained. Consider there is a key called as place, so the value would be Mysore. So basically in a form of key value pair, the data is being stored, you can say in a form of hash map. And in relational database models, basically the data is stored in the form of rows and columns. They have some unique key which uniquely identifies the table. And there are more things in relational database model which is not followed here. So that is why it is called as NoSQL, that is not SQL. Like there are many things people say, but considering like it is a database where we don't use any SQL queries which don't follow any kind of relational databases. So the third one in this list is object-oriented database. So these databases hold objects utilized in object-oriented programming. So you might have heard about OOPS, that is object-oriented programming. What basically OOPS does, it stores everything as object. There are instances of object which is called as class. So basically in object-oriented database, the objects is stored as a form of data which are like instances of class, and the combination of objects and classes is called as object-oriented database. So they work well for the applications with intricate data designs like scientific simulations and multimedia software. So here they are mostly used. Now fourth one is in-memory database. So in this database, data is kept in the primary memory, that is RAM, rather than on a disk, leading to a quicker data retrieval. So basically in-memory database, what we do now, we keep the data in the primary memory, not in the hard disk or not in the SSD. We keep the data in the primary memory, and whenever we keep the data in the primary memory, what it helps now, it helps to improvise the time, as we don't need to make some data retrieval from the SSD, rather than we can make the data retrieval from the primary memory itself. So they are employed in application that demand instant data processing and top-notch performance. Obviously it will give a top-notch performance because the time of consuming the data is very less. We are not consuming data from SSD or from hard disk. So need of database management system. So we got to know about database, databases के types, database management system, what is database management system, and much more things. Now we need to know that what was the basic need of database management system. So DBMS plays a vital role for business, institutions and organizations of all scales in effectively managing their data, ensuring data accuracy and security, and supporting essential decision making process. So basically what happens na ki database management system is kind of having applications at every places, like in schools, like in colleges, like in banks and institution and much more places. It helps to easily manipulate the data, it helps to easily store the data, it helps to manage operations like inserting data, deleting data, doing some manipulation on the data like addition, subtraction and much more things. So it gives us the feasibility to do some manipulations on the data very easily. So that is the reason ki database management system is mostly used. Now the second reason is the security as well. It provides us a lot of security. There are a lot of user access control rules and some authentication rules as well, which would help us and help other people as well ki whenever we are accessing any data, there would be some kind of authorization present, so that that data would be accessible only from me, not from someone else. So it basically helps in data security, achieving security for our data and also the control of the data. So it serves as the core of contemporary information systems, facilitating efficient data management and serving as a basis for a wide range of applications and services. So as told earlier, like it helps to manipulate the data, it helps to perform operations to data, it helps to secure our data, it provides a scalability also for our data, and there are much more things in which database management system could help us. So basically along with the needs, we should also know the advantages of DBMS. So let's see. So basically there are various advantages of DBMS. I've just picked some of them which I thought were important, but there are various advantages of DBMS. So the very first advantage is data security. Who doesn't want their data to be secure? Consider you are in an institution or you are in a college. So no one wants ki your data should be insecure or your data should be visible to every person of the school, or anyone can access your mobile number, your email or the place you live in. So you want your data to be secured. So data security is mostly achieved in DBMS. DBMS implements security mechanism that regulate access to sensitive information, safeguarding it from the unauthorized access and potential data breaches. So the thing which I said earlier, consider there is a phone number of yours which is stored in the database. So there are some kind of security rules, there are some kind of security protocols which helps to provide a layer of protection for all the data, so that no one else from outside world could access your data, make some prank calls to you, or provide you any kind of advertisement. So basically that is the reason data security is something which is utmost important. Now second thing is data redundancy and inconsistency. I explained in the earlier videos as well, data redundancy basically means that same kind of data is kind of being used at different places. Rather we can have a centralized space where all the data for a particular person is present. And data inconsistency is ki consider there are many chunks of data which are present at different places or different registers. What if I correct a data in one of the register or update a data in one of the register and it's not updated in second or third register? There would be a data inconsistency. So DBMS removes all the data redundancy, minimizing storage needs and ensuring consistency throughout the maintenance of a unified version of data. So basically, as I told, in DBMS, we can have a centralized way in which we can store all our data at a central place, so that there won't be any data redundancy and inconsistency in data. So in database management system, now everything happens with a transaction. So in a transaction, what happens, ki consider I am updating a data somewhere. So I need to update data at every places. So even if there is a system failure, transaction would help us to update the data. Either it will there are some many operations, read, write, read, and many operations which we would be seeing in the further videos. But with the help of transactions, we can achieve data consistency and remove the data inconsistency. So the third thing is data integrity. Now, DBMS guarantees data integrity by enforcing some rules or constraints that prohibit the entry of incorrect or inconsistent data into database. So basically, there are some rules in the database which prohibit the insertion of some inconsistent or some data which is not needed to be provided there. So consider there is a column called as age. So in this age, I can't feed the data like ABC, right? So this is not something which is taken care in the earlier systems which we are using, but in databases we can put a constraint that age could only be an integer. So it will not accept the values like ABC, it will only accept the values like 12. So basically we can put some rules, we can put some constraints so that any inconsistent data or any incorrect data is not entered into the database. Now the fourth advantage of database is database scalability. So DBMS can handle large data sets and scale to accommodate increasing amounts of data and as an organization growth. So consider that I am having an organization which is right now having 1 to 40 employees. So in my database, I am having data about all the 40 employees. What if I have a recruitment drive and I hire 1200 more people? So now there would be 1 to 40 employees and there would be some data. So I need to scale my database to that level that I can store all the information of 1240 people. So right now the total number of employees I am having is 1 to 40. Now I need to scale my database to that level that I can store all the information about 1 to 40 employees. So scalability is something which we can achieve in a much more easier way in databases. Fifth advantage is data abstraction. So DBMS offers data abstraction, allowing users and applications to interact with the database without needing to understand its underlying complexities. So there are many complexities, there are many hidden details which are present. So database management system makes sure that there is a data abstraction. So I know that an email is being sent to me from this particular person, but I don't need to know that where that particular person lives, from which server this email has been sent. So there are some complexities or there are some details which needs to be hidden, which are unwanted, or which are some internal details which needs to be hidden, and DBMS helps us to achieve this. So this was all about the advantages of DBMS. So with advantages, there always come some disadvantages, as coin always have two faces. So let's see the disadvantages of database. So the very first disadvantage of database is cost. So acquiring, deploying and sustaining DBMS software can incur significant cost. So obviously if we are sustaining a database, if we are deploying a database, that would be a very costly thing. Furthermore, the hardware essential for proficient operation of database management system can also lead to substantial expenses. So basically whenever we want to maintain a database or sustain a database, there are many operations we need to do to that particular database, and then we also need a hardware which would help us to do that particular operations easily and effectively. So there is increase in the expenses. So database management system can lead to more cost. So that is one of the disadvantage of DBMS. Now the second disadvantage of DBMS is scaling project. Yes, in the advantage I told that we can scale the database management system projects, but there is also a disadvantage with that. Let's see. So when dealing with modest applications and minimal data storage requirements, adopting a comprehensive DBMS could introduce avoidable intricacies and additional burdens. In these instances, more streamlined data storage alternatives could be better suited. So consider I want to store data of only 20%, and I got a database in which I can store data about of 1000 people. So again, that is not making very much sense to me. Yes, that database is scalable, but I know that I only have to store data about of 20 people. It can be 22, but it would never be 100. So scaling projects or scaling, we can see that the projects which require some kind of minimal data storage and adopting a comprehensive DBMS could introduce avoidable intricacies and additional burdens. So if I am I just want a database which store 20 people information and I'm having a huge database, so that is also something which I shouldn't be needed and which would eventually increase the cost, and this will be which would eventually increase the cost, and this would again be a disadvantage of database. Now the third disadvantage is vendor lock-in. So once you have chosen a specific DBMS, it can be challenging to switch to a different one due to differences in the data formats, query languages, and other technical aspects. Then can lead to vendor lock-in where you are dependent on a particular vendor's technology and pricing. So consider right now I'm working on a MySQL database, or a database which uses SQL approaches, SQL query and everything, like relational database. Consider like after a few years, I want to switch to a NoSQL database, which basically stores data in key value pair. So there are some constraints that I can't move from this database to this database because of the formats, because the query being used, because like in this data is being stored in rows and columns, but in this the data is being stored in key and value pair. So there are many constraints which come into picture whenever you are switching from one database to another database. That also leads to one disadvantage of database. So as you can see on my screen, it is made up of two words, data and abstraction. So data basically is a collection of raw facts, and abstraction you can understand in simpler terms is hiding something. So whenever we are hiding some internal information or some internal details which a user doesn't needs to know, it is called as data abstraction. So first let's see the definition and then we will understand with an example. So basically database systems are built with complex ways of organizing data. To make it easier for people to use the database, the creators hide the complicated stuff that users don't need to worry about. The hiding of unnecessary things from user is called as data abstraction. Now let's see from an example. So consider that I am having a database. Okay, this is a student database. Now, I am concerned about what all data I am putting in the student database, like the roll number, student name and different things. But am I concerned about where this database is being stored in my disk? Which memory location this particular database is being stored? No. Like why it matters to me na ki where my database is being stored, in which memory location it is being stored, what kind of data structure it is using for being stored, like B trees or hashing. Like I'm not concerned about all those internal details or all those details which are not concerned to me. I'm just concerned about data at a higher level. I want to do some data manipulation, I want to do some insertion, I want to do some update in the data, but I'm not concerned about where my database is being stored, where the data is being stored in a particular memory location. So I'm not concerned with all those details. So this is data abstraction. The hiding of unnecessary things from users is called as data abstraction. So basically I'm hiding some unnecessary details or some details which is not very much adds a meaning to me. So that particular data that particular information I am hiding from the user. So I am not concerned about where my data is being stored. I'm just concerned about what my data is. Is the data correct? Is the data consistent? Is the data doesn't have any redundancy? So for that particular things I am concerned, but where my data is being stored at a physical storage, what techniques they are using for optimizing, what kind of indexing is going on, for all those details I'm not like very much bothered about. So that is called as data abstraction. We are not very much bothered about details like what is the indexing approach we are using, what kind of data structure we are using for storing the data, at which memory location or disk the data is being stored. I'm not concerned about all those details. So basically this is called as abstraction. Basically we are abstracting something from the user. We are abstracting all those details from the user. User is just interacting with data at a higher level. So there are multiple levels of abstraction. So let's see about all those levels. So there are 3 levels of abstraction. Let's see about all those 3 levels. So the first level is called as physical level, which is, you can say, the lowest level. Now the second one is logical level. And the third one is called as view level. So let's understand about all these levels of abstraction from an example. So first let's start with the definition, and then we will be looking at an example, and we will be understanding all these three levels from the same example. So first level is physical level. So this is the lowest level of data abstraction. It describes how data is actually stored in the database. You can get the complex data structure details at this level. So let's take an example. Again, the same example which I took in the last slide. So I am having a student DB, student database. Okay. Now this level tells me how data is actually stored. So consider I am having this student database. There are many datas in this particular table or the database. Now consider that this particular element or this particular database is being stored at a memory location. Or you can say SSD, hard disk, anything. So basically it is being stored physically at a storage location. So in this physical level, we get to know that where the data is being stored. So at this level, now what you can do, you can also optimize your data. So how you can optimize your database is key. You can perform some techniques. You can use some data structures which will help you in proper optimization. Like there are B trees, hash map, and many thing hashing. So you can use that particular approaches and that particular methods to optimize your database. So basically here you are just concerned about where your data is being stored. In a simpler terms, so I am having a student database and I am only concerned about where the student database is being stored. Simple. Now going to the logical level. So basically logical level, can you relate with the term logical? So whenever we are doing something logical, some logical operations are being performed, like creation of a database, adding some constraints into database, identifying what is the relationship among the data elements, like these all things are taken care in the logical level. So this is the middle level of 3-level abstraction architecture. It describes what data is stored in database. So here basically it was all about how data is stored, and in this level we were concerned about what data is stored. So basically coming to the same example, now I know that there is a student database. Now I am making some tables. Consider there is a student table. Consider there is a table with student fee details or something like that. So there are multiple tables for student table which is having details about their first name, last name, roll number, and etc. Student fee details where they are having all the details about when they paid the fees, what were their fees, and how much money they have paid together, like some details like this. So basically at logical level what we do na, ki we make some tables like student, we provide some data to them, then we establish some relationship among them, or we identify that what is the relationship between the student name or student roll number or the student fee details and various things. So basically all the logical things like creation of a student table, then addition of some attributes, addition of some tuples in that particular student table. So attributes basically means columns, tuples basically means rows. So addition of some rows and columns into the student table, then providing a unique identity that consider that ID. So ID is something which is unique, not all the students would be having the same ID. So providing some constraints, and like much more things are done at a logical level. So basically in logical level we are not very much concerned about where our data is being stored or what all things. We are just concerned about what data is being stored. Okay, so the very third level is the view level. So highest level of abstraction is called as view level. This level describes the user interaction with database system. So again taking the same example, now consider there is a student database, right? So consider I am a teacher and my friend is someone who is working in the accounts team. Okay. So as a teacher, I would need some details of student like roll number, subjects, student ID. And as someone who is from account team, they would need details like student fees, paid in the month or month, like these details. So according to the need, I can have multiple tables. Like if I am someone who is from the account team, I am majorly concerned about what is the student fee details, in which month they have paid, till which months they have already paid, till which month it is pending, like all those details which is needed to me. At a teacher level, I would be just concerned about what the student name is, what additional subject they have taken, or what is their roll number, or what is their student ID. So in the view level, what happens now, there are multiple there are multiple views which we can see, and which gives us you can say which gives us the opportunity to only see that particular data which concerns to me. Consider that I am in a school, right? So my principal can see all the data related to student, related to teachers, related to staffs. Now coming to teachers, teachers can see all the data related to students. Now coming to students, student couldn't see any data, right? So firstly, we will start with schema, and then we will see what is instance. So schema. A schema is a logical container or a structure that organizes and defines the structure of a database. It identifies how data is organized, what data types are being used, what constraints are applied, the relationships between different pieces of data. A schema acts as a blueprint for the database, ensuring data integrity, consistency, and efficient data retrieval. So let's understand from an example, okay? So in programming terms, we always give like int a. So what does this mean? A is a variable which is stored at a memory location, and its data type is int. So we can only store integer type values in A, and A is stored at a particular memory location. Now in A, we can give the value as 2. Either we can give the value as 3. Either we can give a value as 21. We can give any value which would be integer. But A remains at the same place at the same memory location. So in the same way, what is schema? Schema is basically now a blueprint of the database. So consider I am creating a database of customer. Okay. So for this, what I need to do is first I need to make a customer table. So we will be first making a customer table. Second, I need to give some rows and columns in this particular customer table. Okay. At the third place, what I'll give, that I will give some field names or some column names and provide the data type they can hold. Now, in the fourth number, we will be defining the constraints in that particular DB. So let's see. So basically consider that this is my customer table. Now customer table would be having some rows and some columns. So right now consider it is having 2 rows and 3 columns. Okay. Rows is 2, columns is 3. Now consider that they would be having some column names as well. So consider I am giving this column name as ID, this as customer name, and this as customer address. Okay. Now I have given the rows, I have given the columns, I have given the names to the column. Now I need to provide the data type. So ID would be something which would holding an integer value. Name would be something which would be holding a character value, and address the same character value. And we can provide the size as well for the same, like consider 8 digits, 14. Okay. So I have given the data type, and I have given the limit of that particular data type. Now ID is something which would be unique for all the customer, because it is generated at the time of, you can say at the time of billing, or at the time of we are feeding the entry of customer into our table. So ID is something which is very unique. So we can provide, or we can say this ID is a primary key for my table. So it is a primary key. So basically constraints in DB, all these things we have done in this particular schema. So now In id I can like give any value. Either I can give 1 2 3, I can give 4 5 6, I can give 7 8 9, I can give any value which would be of type integer. So basically I am giving a blueprint of my database here. So schema is a blueprint for the database which ensures data integrity. Like I can't put on any value which is apart from int in this customer id. Data consistency, that my data remains constant throughout all the databases or throughout all the table. There won't be any duplicacy. And efficient data retrieval. So if I am having id, I can retrieve the data for any of the customers. Now here we have defined the data types, we have defined the constraints, we have defined the relationship between different pieces of data. So this is called as schema. Now there are various types of schema, so let's understand about that. So types of schema. The first schema is called as physical schema. Are you getting something? In the last set of videos we discussed about physical level in abstraction. So it is kind of similar to physical level of abstraction. So physical schema. In a physical schema, it defines how the data is stored on the underlying hardware, including details such as storage format, file organization, indexing methods, and data placement. So basically in physical schema, now we basically deal with the physical terms like where my data is particularly stored. So in physical schema, I am concerned about where my data is stored on the hardware or disk or any memory space. So consider that my data is stored at this particular memory. Okay. So at this particular memory space, my DB is stored. Now I can see some of the methods of storing the data in the database. Like I can use the hashing method, I can use the B tree method. Like there are many methods, there are many indexing methods which we can use, so that when we are querying and when we want the data, there should be a proper optimization which is established. So if I use like the file organization techniques, the indexing techniques, indexing methods, indexing techniques, then I could get my data very easily and very effectively, and it can also help in optimizing the data, and also these methods would help in the storage optimization as well. So in the physical schema, we basically deal about how the data is stored in the hardware or in the disk or in the memory space. Now what are the characteristics of physical schema? So it primarily lies in enhancing the storage and retrieval of data to boost the performance. Again, the same thing which I told in the last slide, that we make sure that we put the data in a proper place, in a proper storage or in a proper memory, so that it can be very easy for us to retrieve that data, and also it could help in the storage optimization, which would eventually lead to boosting of the performance. Now the second one is modification means to the physical schema demand meticulous planning and can potentially affect the overall performance of the database. So basically consider that my database is at one particular location. Now I am moving that database to another location. Then again I need to be concerned about how the data is being stored, what all methods of indexing we are using, how the data is being stored, how I can retrieve the data, what is the time it is taking for the data retrieval, what is the storage optimization. So there are many things. So if there are some modification made to the physical schema, it could potentially affect the overall performance of the database, because right now the data is stored in such a way that it gives me the higher performance, it takes lower time and gives the higher performance. But there could be a chances that if the modification is made, it could take more time, which could lead to a lower performance. Now the example, deciding to use clustered index on specific columns for a faster retrieval. As I told that we use some indexing methods. About all these indexing methods we would be knowing in the coming videos, but you just understand in a way that there are many methods. We use some of the methods to on specific columns for getting the data as fast as possible. Now the second schema is logical schema. A logical schema defines the database structure from a logical or conceptual perspective without considering how the data is physically stored. Now in the physical schema, we were majorly focusing on how the data is stored. Now here we would be focusing more on what data is stored. So I'm not concerned about wherever my data is stored in the memory location. I am mostly concerned about what kind of data is being stored. So logical schema is of two types. First one is conceptual schema and second one is external or view schema. See, all these terms we have already read in the abstraction video, the types of level. So it is kind of similar to that, but still I'm trying a lot to make you understand again that what all these terms basically mean. Now, the types of logical schema. So the first one is conceptual schema. The conceptual schema represents the overall view of the entire database. It defines the high-level structure and relationships between all the data elements. The example which I told in the schema, that we are making a blueprint of all the columns, all the rows. We are giving some data types to these particular columns, like ID can have only integer values, name can have only character values, and like this. So basically we are defining a database, we are making tables, we are making rows, we are making columns, we are giving the data types, we are identifying the relationship between them, and we are also adding some constraints like ID is something which is unique for every customer, so that can be a primary key. Again, for the keys we will be knowing about it in the next set of videos, but just understand in a way ki something which is unique, something which can't be like something which shouldn't be twice or shouldn't exist twice. So consider that there is a customer ID. So every time whenever you are generating a customer ID, it would be a random thing. So one time my customer ID could be 1, 2, 3. One time it could be 4, 5, 6. It could be 7, 8, 9. But again, it couldn't be 1, 2, 3. So there won't be any case where customer ID which is generated for every person, consider it is generated for A, it is generated for B, it is generated for C. For D also, the customer ID remains the same, which is of A. It won't be possible. So there are some constraints, there are some columns, there are some rows which we define for a particular schema. It would be a better word to call. So for a particular schema, we define everything. So in conceptual schema, it basically depends on that what are the relationships we are giving for that particular schema, what is the number of rows, what is the number of columns, what is the data types. Now the second one is external or view schema. An external schema defines the user-specific views of the database. It focuses on the portion of database that are relevant to specific user, roles or application. So consider that there is a database of customer. Okay. Let's take an example of an e-commerce website. So in e-commerce website, there would be many tables. One table would be of customer. Second table would be of orders the customer had made. Third table would be the prices for all the things and then discount and everything. So there would be 3 tables present. Like there would be many tables, but I am just taking an example of 3 tables. So consider I am a person who is working in the sales team of this e-commerce website. So if I'm working in the sales team, I would be mostly concerned about what all prices customer has paid, what is the total amount the customer has paid, what was the total discount it got, how the sales are increasing, and much more things. So I would be mostly concerned about some specific table. If I am someone who is like seeing the analysis like what all things customer buys and how I should recommend the customer to buy the same thing, I would see the orders table. So basically according to the users we show different tables or we show different views. So in this view schema, what we do is there are different views, and according to the user specifications, like I want to see the sales, I want to see the data related to customer, I want to see the data related to what all orders customer place and different things. So in this way there are different views, and these are user specifications on which the views are shown. So in this schema basically defines the user specific views of the database. So basically here it is a customer, here it is an order, and here it is a price table. Okay, so there are some characteristics as well of logical schema. So it delineates how data is structured into tables, the interconnection between these tables, and the restriction placed on data. Again, the same thing that the data could be only of type integer, what all relationships are between the tables, and what are the number of rows, number of columns, and much more things. So basically it delineates how the data is structured into the table. Now second point is logical schema prioritize data modeling and database decide over considerations related to hardware or storage specifications. Again, we don't need to be much more aware about like how the storage, where the data is being stored or something like that. I'm not concerned about that. I'm basically concerned about like how my database is being designed, how much tables are there, how much rows are there. I'm mostly concerned about what data is stored. I'm not concerned about how my data is being stored in the memory space. Example, defining tables, specifying primary and foreign keys, creating views for the data access. So these are the examples for logical schema. Now the last term in this video is instance. So what is an instance? The information residing within a database at a specific point in time is referred to as database instance. So consider that today I made a database. Okay, it is a customer database. So right now I am having 3 customer 1, customer 2, customer 3. Okay, so I am having a database of customer 1, like how many orders the customer has made, like orders the customer has made. Consider that this customer has made, just give me a second, let me make a bigger table for you. Okay, so this is a customer table. ID, number of orders, and I can give the address. Okay, so ID is 1, number of orders is 2, address is Delhi. ID is 2, number of orders remains 5, and ID is address is Bangalore. Okay, so there is one customer which is having an ID 1. The number of orders they have made, total orders is 2, and they reside in Delhi. The ID is 2, the number of orders they have made is 5, and the address where they reside is Bangalore. Now there could be a possibility na ki right now I am living in Delhi, but what if I switch to some other place or some other state like Karnataka? So right now I am working in Delhi, but I have changed my job, and right now I am going to Karnataka. So I am relocating to Karnataka. So I would request the website, like we can take an example of Swiggy. So right now I am in Jharkhand, that is my hometown. I am making orders on Swiggy. I am giving my address. Now I am switched to, like I have came to Bangalore. Now I want the order delivered to be delivered at my Bangalore's address, right? So I'll make some update ki okay, right now that was my home address, but now the home address is the Bangalore one. So there would be some update in the database regularly, right? So at an instance, consider at this particular time, this is the data which is stored in the database. There would be some modification made in coming days. So the information residing within a database at a specific point of time is referred to as database instance. So basically the data which is there in my database at the specific point of time is called as instance. Within a given database schema, the declaration of variables within a tables pertain to that specific database. The term instance in the context denotes the current values of the variable at a particular moment in time for the database. So at an instance, the value of address is Delhi, but ho sakta hai after 2 days the address is changed to Bangalore. So at a particular instance, the address is Delhi, but after 2 days, if that particular specific time, if we see, the address could be Bangalore. So in this context, it denotes the current values of the variable at a particular moment in time for that particular database. So schema is basically a physical representation of database or a blueprint of database. Instance is the value of database at that particular specific point of time. So basically, database management system architecture refers to the structural framework and organization of database management system. How we are just organizing our database, like what are all the elements of the database we are using. Consider that I am designing a database system. So how many elements I would be using, how many clients would be there, how many servers would be there, how many databases would be there. Like there are many things, right? Whenever we design a system, we majorly be concerned about what all databases would be there, what all clients would be there, what all servers would be there. So basically it helps in organization of a database management system, that is DBMS architecture. It also defines how the various components of the system work together to store, manage, and retrieve data efficiently. So basically in this DBMS architecture, now there are like different types of DBMS architecture existing. We would be mainly knowing about three architectures. In simpler terms, you can understand that DBMS architectures help us to achieve a way in which we can organize our data, store our data, access our data. We can manage, or we can organize the database systems. We can manage how many clients would be there, how many servers would be there. According to our requirements, we can select the tier level of databases. So basically, according to the user level, you can select any kind of databases, either it be 1 tier, either it be 2 tier, either it be 3 tier, or either it be n tier. Basis on your requirement, you can select any of the tiers of data. So let's understand about the types of DBMS architecture. So there are basically several types of DBMS architecture. Choice of architecture basically depends on the factors such as type of database, that could be relational or NoSQL, and the specific needs of the application. So it mostly depends on how my application is. Like if I am having a website which is handling so much of traffic in a single day, so I would be using a database in which I can achieve scalability at a good level, right? So there are many user requirements, there are many organizational requirements according to which we select the database. So there are three architecture basically about which we would be learning in this video. There are more architectures ahead, like centralized architecture, n-tier architecture, and much more. But here we would be knowing much more depth about the three tiers of architecture. So the first one is 1-tier architecture, the second one is 2-tier architecture, and the third one is 3-tier architecture. The 1 tier, 2 tier, and 3 tier, you can see that 1, 2, and 3 are being used. So it is kind of related to the database designing or the database system which is present for these level of architectures. So let's see for the 1 tier architecture. So in the 1 tier architecture, the entire database application, including the user interface, application logic, and data storage, resides on a single machine or computer. So basically, whenever you have the database installed in your computer and you are accessing that database, for consider that whenever you are learning SQL, you are performing some SQL queries, you are seeing the result, you are making some data, you are making some table, and on that tables you are manipulating or making any type of query. So you are making that query in your system, right? So client, user interface, and database, if all the three are in the same system, it is called as 1-tier architecture. So here you can see that data storage resides on a single machine or a computer, and the three things are the user interface, application logic, and the data storage. So basically an example could be an illustration of straightforward single tier architecture can be seen when you install a database on your system and use it to practice SQL queries, as I told. So basically this is the file server, and this is a PC tablet or anything. So basically in my PC tablet, I just installed a database software and I am using it for making some SQL queries. So that is called as 1-tier architecture. Now coming to the 2-tier architecture. In 2-tier architecture, the presentation layer runs on a client, that could be PC, mobile, tablet, etc. and data is stored on a server. So basically 2-tier, there would be two things, right? In 1 tier, there was only one thing, like the client, the user interface, the storage, everything resides in a single entity. But here there would be two entities. The 2-tier architecture provides added security to the DBMS as it is not exposed to the end user directly. It also provides direct and faster communication. So let's understand from the diagram as well. So as you can see, this is a 2-tier architecture. This is a client 1. And this is my client 2. Now this client 1 and this client 2 are interacting with this server, which is a database. So here you can see now that there is a presentation layer, or there is a layer of security, that this particular client and this particular client are making requests to this database. Right, so there are multiple clients who are making requests to a single database. or a single server, you can say. So there are multiple clients and they are making requests to a single server. So two tier basically means there would be two entities. First one is a client entity, second one is the server entity. The client is making some requests to the server and the server is making some manipulations and doing some manipulation and returning that as a response to the client. So you can consider an example of a workstation where there are multiple computers and all can query into the same database and work with the same database. So there are multiple computers, there are multiple clients, and they are querying to same server. So this is a two-tier architecture. So basically, just to give you an overview, in one-tier architecture, the client as well as the server used to reside in a single entity. And in the two-tier architecture, the client and a server used to interact using a layer. So this is the basic difference, that in one tier, the client, the server used to be in a single entity. Like if I am installing a database software in my system, so that is a one tier architecture, because I am installing it in my system. I am using that to make multiple queries, but that particular server couldn't be used by any other person or any other person. Like it can be only accessed on my laptop. No other person who is having a different laptop can access that particular server, right? So that is like in my computer, I am having a software, I am using that software, I am making some SQL queries and it is giving me results. Now when I switch to two-tier architecture, there might be multiple computers who would be reaching towards the same server. This is also called as client-server architecture. Client is like computer, PCs, tablet, and server is where our database resides. So basically, three-tier architecture, what happens? As the name suggests, 3 tiers. So there might be 3 levels of layers, or 3 levels would be there. So basically, it separates the application into 3 logically distinct layers: presentation, application, and data layer. So basically what happens at 3 level architecture, now there is a distinction, there is a layer separation. The first one is a presentation layer, the second one is the application layer, and the third one is the data layer. So basically there are 3 levels of separation of these layers. Like the first layer is like the client layer, the second layer is the application layer, and the third layer is the data layer, or you can say all the databases are present there. So basically, let's understand about the layers, and then we will see with a diagram and understand about this architecture. So basically, presentation layer, it handles the user interface. So basically, whenever we go to any website, consider we are going to Swiggy. So whenever we see Swiggy on our website or see Swiggy app on our mobile application, what we see? We see a page where all the menus are present, all the restaurants are present, all the food items are present. So that is called as UI. So whenever we are accessing any of the website, either through app or through web, we get a UI, which is the front end of the application, where we see every details, like the orders, like my what are the restaurants which are onboarded, what are the food items which are present. So basically that is called the front end. So basically in the presentation layer, that is also called as front end layer, we basically deal with the user interface of the application or the like website. So in example, you can see your PC, tablet, mobile, etc. Now the second layer is application layer. So it manages the business logic example server. So basically what happens now? Now we have seen the UI. Now consider I am at swiggy.com. I want to order some food. So for ordering some food, what I'll do, I'll select particular restaurant. I'll just add it into my cart and I'll just place the order. So there would be some kind of business logic, or there would be some kind of logical operations which would be going on, like the addition, like the deletion of that particular thing from your cart, or the addition of particular thing in your cart. So there are some manipulations which are done. So basically all that logics now that take place into logic layer or the application layer. Now the very third layer is the data layer. As the name suggests, it would be something related to database. So basically it manages data storage and processing. Example, the database server. So it basically what database does is, store our data, manage our data, and do some processing on that particular data. So on the data layer, there is a database where all the managing of the data, processing of the data, and all other things takes place. Now let's see the diagram of this particular architecture, and we will get a more good overview about this architecture. So basically, as you can see, there are 3 layers: client layer, server layer or application layer, and data layer. Now, in the client layer, we basically deal with the UI, which is called as user interface. So basically consider Swiggy.com. So whenever we open the app, we can see some restaurants. And then whenever we open that restaurants, we can see their menu, then some food items and etc. So this is the landing page. So basically that is called as UI or user interface. Now in the second layer, consider I am like having a craving of eating chocolates. Okay. So what I'll do, I'll go to Swiggy Instamart and I will add some chocolates into my cart. Okay, so basically whatever I am doing, the addition, it is kind of a logical operation, and that is happening at an application layer. Now at the very third layer, what is that? That is a data layer. So in the data layer, if I am adding something to my cart, there would be a database with called as orders. So in that orders, this particular thing would be feeded. So there would be a storing of data, also processing of data. So all these 3 things now take place, and all these 3 things like the presentation layer, application layer, and data layer, they are not dependent upon each other. They have different infrastructures. So we can like make application more scalable by using by broadening this particular layer or another layer or different layers. So basically they all have their own infrastructure. So we can broaden our application, we can scale our application accordingly, because one layer doesn't affect the other layer. So we can make changes at one layer, we can use the scalability principles and much more things to scale our application. So all of them have a different infrastructure. That is why the 3-tier architecture is the most used architecture, because again, here we are getting an extra security of the application layer where all the business logics is happening. The client layer is not directly talking to the database layer. There is an application layer in between, and there are much more things. We can scale our application, and there are many advantages. So we would be seeing about the advantages in the next slide. Okay, so this is the advantages of 3-tier architecture. So the very first advantage is, as I told, the scalability. So basically it is easy to adjust each tier to handle changing user demands. As I told that each tier have their different infrastructure. So if we are having any kind of user requirements, we can do any kind of manipulation at any layer which won't affect the another layer. Now the second thing is modularity and maintainability. Simplify maintenance by separating responsibilities. Again, the same thing, that the client layer has other responsibilities. It is responsible for the UI. The server layer or the application layer is basically responsible for all the logical operations which is happening, and the data layer is mostly responsible for all the processing which is happening in the database and also storing the data. So all of the layers have their different responsibilities, so it is very easy to maintain. Now the third point is security. Protect sensitive data with an additional layer. As I told that there is an additional layer of application layer, and client is not directly interacting with the database. So there is an additional layer of protection which helps in the security purpose and also in the scalability purpose, as none of them are dependent on each other. Performance, optimizing presentation and application tiers for better performance. As I told that we can optimize any of the layers, but they are not dependent upon each other. They have their own infrastructure, so we can optimize them according to the user requirements to get some better performance and better optimization. Now with the advantages, always there comes a disadvantage, because every coin has 2 faces. So let's see the disadvantages as well. So the disadvantage of 3-tier architecture, it includes increased complexity. Obviously there has been an introduction of an extra layer which is doing all the logical operations. So the complexity is kind of being increased as the level of tiers of architecture increases. Now the second thing is potential latency issues. So you might find some of the latency issues as well, because there are 3 tiers of architecture, and there might be some issues which would be encountered. Consider there could be issues like when we are like talking to the database layer, there could be issues in manipulating the data, there could be some issues in processing the data. There are many potential issues which could be encountered while doing any manipulation at any of the levels. Now the third thing is longer development time. Again, 3 tiers are involved. So at one level you need to code all the logic, that at one level you need to design the front end of the application, then at one level you need to design the back end of the application. So the development time increases, because again the client is not directly talking to the database, it is talking it via application layer. Then resource overhead and possibility of bottlenecks. Because of complexity of the database, there are much more things which are being introduced, because this is a bit complex tier architecture. So there might be like complexities which could arise in each and every moment of time. Again, longer development time because of 3 tiers architecture, then overheads, then there are many things, latency issues, overhead, bottleneckings, and much more things which is involved, because of which these are coming as a disadvantages of 3-tier architecture. But it is kind of mostly used in the companies and mostly used everywhere, because 3-tier architecture is a place where like you are dealing with the front end client layer, you are dealing with the back end data layer, and you have an additional layer, application layer, where all the business logics is being happen. So if you want to change some business logic, or if you want to do some alteration, you don't need to do alteration at all the levels. You can just go and alter, like update or alter anything at the business or application layer. So that is the major thing, that it is helping us to there is a layer by layer protection. Also it is helping us to achieve optimization. It is also helping us to achieve scalability at a very good level. So that is why 3-tier architecture is mostly used. So this was all about this video. I hope you like this video. So if you're liking this series, please hit the like button. It gives a lot of motivation to make videos. Also, if you're very new to my channel, you can have a look at all the videos, and if you find it useful, you can also subscribe to my channel and share it among your friends. Till then, take care, keep learning, keep growing. Bye all.